Jai Shri Gurudev. Good morning to everyone students. Welcome to chemistry class. The next concept is stereochemical aspects of haloalkanes and haloarenes. Here the stereochemical aspects is nothing but spatial arrangement of atoms or groups around a carbon atom in different ways or in different planes. It means, for example, take a carbon atom. If it having 4 different groups or 4 different atoms, like you take a methane or any other group, if you take methane CH4, here there is 4 hydrogens. Those 4 hydrogens is arranged like that. One hydrogen is above the plane and one hydrogen is below the plane, and remaining 2 hydrogens are on the plane like that. This is the spatial arrangement of atoms around a carbon atom. This is called as stereochemical aspect or stereochemical structure. If these 4 hydrogens is replaced by putting different atoms, for example, out of 4, one is hydrogen and one is chlorine and one is hydroxyl group and one is CH3 group. Like that we are putting 4 groups, 1, 2 and 3 and 4. It means one is hydrogen and another one is hydroxyl group OH, and remaining one is means third one is CH3 and the last one is Cl. Like that we are putting 4 different groups in different manner. So here observe, this chlorine is above the plane and CH3 is below the plane, OH is on the plane and H and OH is same plane. This is called as chiral atom. Chiral atom. It means the carbon atom which having 4 different groups or atoms is called as a chiral molecule. Chiral molecule or chiral compound. Here Cl is above the plane and OH is on the plane, CH3 is below the plane. Or if in place of Cl there is a CH3 and in place of CH3 there is Cl, get one more molecule right. These two are identical, but actually those chemical properties is totally differ due to the stereochemical changes, and such compound shows different medicinal properties also. Okay, so that the stereochemical aspects is very important in industrial field or medicinal field or chemical field, wherever we are using chemistry. Okay, so now we are going to study the stereochemical aspects of haloalkanes and haloarenes. Here we are to study some basic terminologies. Those are used in stereochemical aspects. Now the first one is plain polarized light. You know, ordinary light or sunlight. So observe this ordinary light or sunlight. This is the ordinary light. Ordinary light, or we also called as sunlight. It means the light radiation is coming from sun. These light radiations or ordinary light is polarized in all possible directions. Okay, this is polarized like that, all possible directions like that. It means the polarization is nothing but moving all directions. This polarized light is passes through a nickel prism. This is the polarizer. We call it polarizer. Here we are using nickel prism. Nickel prism, we call it polarizer. This ordinary light is passes to the nickel prism. We are passing to the nickel prism. This converted into plain polarized light. This plain polarized light is polarized only one direction. Plain polarized light. So this is the plain polarized light. When you get plain polarized light, when ordinary light is passes through the nickel prism, you get a plain polarized light. This having only one direction. You get a light that having only one direction called plain polarized light. Okay, I hope you understand what is meant by plain polarized light. Then the next terminology is optical activity. When the plane polarized light is passes through a solution of a compound, the plane polarized light is rotated in 2 directions, either clockwise direction or anti-clockwise direction. If it rotates, that is called that is called optical active, and the compound is said to be optical activity. Optical activity is called as optical active compound. So listen, optical activity is nothing but it is a phenomenon in which when plane polarized light is passes through a solution of an organic compound, the plane polarized light is rotated either clockwise or anti-clockwise, is called as optical activity, and the compound is called as optical active compound. Okay, here the plane polarized light is only the rotator. So if light is rotated clockwise, means andre ಗಡಿಯಾರ ತಿರುಗೋ side clockwise, that we called as dextrorotatory. If the light is rotated anti-clockwise, means opposite to the clockwise, we called levorotatory. This dextrorotatory is indicated by the symbol D. Hard place, very important, these two, and levorotatory is indicated by the symbol L or minus. So what is mean by dextrorotatory? Dextrorotatory is nothing but when plane polarized light is passes to the solution of an organic compound, the light is rotated clockwise direction, is called as dextrorotatory. Similarly, when plane polarized light is passes to the solution of an optically active compound, it rotates levorotatory, means it rotates anti-clockwise direction. The compound, the process is called as levorotatory and is indicated by L or minus. Okay, so this is the concept of optical activity and dextrorotatory and levorotatory. Then next one is a chiral compound or chiral molecule. Chiral molecule or chiral compound, it is defined as a compound that containing 4 different groups or atoms is called as a chiral molecule or chiral compound. So example lactic acid. So here observe the structure of lactic acid is carbon, it containing COOH group and OH group, then hydrogen and CH3. So this is the structure of lactic acid. Now here the carbon containing 4 different groups, right? Hence the compound we call as a chiral compound. If we call this is a molecule, we call it chiral molecule, right? Now there are 2 types of lactic acid, that is dextrorotatory lactic acid and levorotatory lactic acid. If observe, this compound is dextrorotatory, it means when plane polarized light, observe this is the plane polarized light representation. This plane polarized light is passing to the solution of this lactic acid. We are taking this lactic acid solution, this is lactic acid solution, we are taking solution of lactic acid. If when we are passing this plane polarized light into lactic acid solution, this lactic acid is rotated clockwise direction, like that, rotate clockwise direction called dextrorotatory, or we also called as D R plus isomer, right? Similarly, if when we are passing plane polarized light into the solution of lactic acid, the light is rotated in anti-clockwise direction. This is anti-clockwise, like that. Then we called as levorotatory. Okay. So here the compound that contain 4 different groups or elements, then only it should be an optical active, that is the condition of optical activity. Okay, the condition of optical activity is the compound must be containing 4 different groups or atoms. 4 different groups are atoms are involved. This is the optical activity. Example lactic acid. Then take next one, enantiomers. So enantiomers is a pair of isomers which are non-superimposable mirror images. That is the pair of isomers which are which are non-superimposable mirror images. Is called enantiomers. For example, observe, if you take our two hands, these two hands are mirror images, right? Observe, these two hands are mirror images, but these two are not superimposable like that. Means these same fingers of one hand, means right hand, is not placed on exactly the fingers of left hand. Such type of compounds we called as enantiomers. Example, take lactic acid only. This is simple and easiest one. You know the structure, lactic acid. Example, lactic acid. So write the structure: carbon, COOH and OH. Then hydrogen and CH3. Okay, this is the lactic acid. Now put mirror here. So when we are writing like dotted lines, this is the mirror. We are assuming this dotted lines is what? Mirror. So when we are putting mirror, the COOH is reflected here, right? So write carbon, this one, and reflected COOH. Exact its mirror image reflected. Then OH, that is OH. And here hydrogen, it will be reflected here only. Then CH3, that is CH3. So observe, these two is what? Mirror images. But when this molecule is placed on here, the COH is put on OH and OH is put on the COH. And these two are placed exactly these two. But all atoms are not placed exactly on same atoms or groups. Hence, these two we called as what? Enantiomers. These two we called as enantiomers. Hence, the enantiomers is defined as non-superimposable mirror images pair is called enantiomers. Now, these two mixtures, one is rotated clockwise, hence we call D, and if another is rotated hell, we call levo, or levo side we call hell. So observe, by passing plane polarized light, it rotates like that. Means clockwise rotate, it is called dextroisomers, indicated by D or place. If this compound is rotated anti-clockwise, means like that, or like anti-clockwise. Like this is anti-clockwise direction, right? If we rotate like that, we call L or minus L isomer. Now these two isomers are having the same physical properties. Hence we cannot be separated on the basis of physical properties. However, we can separate on the basis of chemical properties. Okay, so ಏನೇನು physical properties ಮೇಲೆ separate ಮಾಡಕ್ಕಾಗೋದಿಲ್ಲ, ಆದರೆ chemical properties ಮೇಲೆ separate ಮಾಡಬಹುದು, because these two are stereoisomers. Now the mixture of these two we called as mixture of these two is called as enantiomeric mixture. So what we call enantiomeric mixture or racemic mixture, that is enantiomeric mixture or racemic mixture. Racemic mixture. So racemic mixture is defined as the mixture of D and L isomers. Racemic mixture is a mixture of an equal mixture of D and L isomers is called racemic mixture. Example, the mixture of L-lactic acid and D-lactic acid. This is called D-lactic acid, this is L-lactic acid. These two equal mixture we called as what? Racemic mixture. Then the process of separation of D and L isomers is called as racemization. So racemization is the process of separation of D and L isomers. Racemization. Racemization is a process of separation of D and L isomers. separation of D and L isomers is called as racemization. Then the next concept is inversion of configuration or retention of configuration. So the next concept is inversion and retention of configuration. Now to understand this, take a compound which is arranged in three-dimensional manner. For example, take a carbon atom which having 4 different elements. One is above the plane and one is below the plane, and remaining these two are on the plane. Let's take this is A and B, C is there, D, E. So this is the spatial arrangement of atoms or groups around a carbon atom. If you take a nucleophile, that nucleophile Nu minus we are representing generally. If among these, this is E is a living group, let's take in place of E, take L. L is nothing but what? Living group. If nucleophile will be attacked in the same direction, means same side, this living group will be eliminated here as L minus, right? So you get a compound and the nucleophile is be substituted in place of L. What type of compound you get? C, La, and which is above the plane, what? B, and which is below the plane, D, and in place of L what you get? Nucleophile Nu. So observe these two have same configuration. Just in place of L we are putting Nu, that is nucleophile. This is called as retention of configuration. Retention of configuration means the configuration will be retained same as it is. Andre idake ideo configuration ade configuration ಇಲ್ಲಿ ಬಂದಿದೆ ಅಂತ ಅರ್ಥ. So similarly, if you take a nucleophile Nu, now this nucleophile get attached to the opposite direction of L.